Nice to meet you here on YouTube channel. And I need to thank my students. They motivated me to start this channel. So hopefully through the channel, I can pass on the knowledge I have learned in mathematics and the little understanding I have in basic mathematics. So I think personally, fundamental mathematics covers 3 categories. So the first category is expressions. Then the second one is equations. Then under equations, we have a functions family. So expressions like numbers, right? The real numbers, we all know. How is real number defined? If we multiply any real number by itself, it's the square of the number has to be non-negative. In mathematics, that is to say, has to be greater than or equal to 0, or at least 0. So we have a rational family, rational number family, like integers, counting numbers, whole numbers, and also have irrational family. So basically, under numbers in fundamental mathematics or basic mathematics, we have 2 families of numbers. One is called real number, and the other one is called imaginary number. So for real numbers, if you square any number, it cannot be negative. So we define something called imaginary number, which means we did make such I when we square it equals to -1. So just to make the rest of for real number who cannot cover. So with real numbers and imaginary numbers mixed together, we call complex numbers. So under real numbers, we have a rational family, which rational means the number makes sense to human brain. Let's say -100, right? Maybe we spend $100, or maybe we owe someone $100, or maybe we borrowed $100 from the bank, so on and so forth. So we use a negative number to record certain information. And 0, just 0, right? 0 represents nothing, but 0 is such important number in mathematics. We will see, you will see later. I like to call 0 and 1 are transformers, because in mathematics, we'll always add 0 to an expression, because we want to manipulate expressions sometimes. We want to write expression from one form to another form. So oftentimes we add 0. Let's see, if we need completing squares, we need +1. But with the expression or with the equation, we cannot just +1. We can only +0. So +0 means we add a number, we subtract the number simultaneously. So 1 is the same thing. 1, we like multiply by 1. When we add 2 fractions, subtract 2 fractions, we need common denominators. So what do? We often multiply by 1, and this 1 is a certain number divides itself. So 0 is a number subtract itself. 1 is a number divides itself. So those numbers are most important numbers in mathematics. With algebra manipulation, we use those 2 numbers all the time. Or fractions. This is a mix of fractions. This fraction means 2 plus 305. But oftentimes we just write it as a mixed number. A whole number part 2 with a fraction part 3/5. So some students I know have a difficult understanding about fractions. But if you think this way, what is a 3/5, right? You can think as 3 apples shared by 5 people. How many apples each one gets? Each one gets 3/5 of the apple. So rational numbers versus irrational numbers. Irrational numbers means irrational. Doesn't really make sense to human brains yet. Like square root 2. What is square root 2? I have videos to show how to understand how to picture square root 2, such irrational numbers. We can approximate, right? If we punch into a calculator, the calculator will tell us it's 1.14, Depends on how expensive the calculator is or how advanced the calculator is. You may get more decimals as you get a more expensive calculator or more advanced calculator, because they're just calculating more decimals. Two famous numbers, pi, right, to deal with circles, and the Euler numbers to deal with logarithm. We use those two numbers. So under rational numbers, one important family is counting numbers, right? How many apples we have? We start from 1, 1, 2, 3, 4, 5. And those are called counting numbers. Then if we add 0 to the counting numbers, that set is called a whole number. Whole number. The difference between counting number and whole number is just one number, 0. Then integers. Integers, we have a whole number plus a negative counting number. So 0 sits in the middle, right? And we have negative numbers, we have positive numbers, so the integer family. And fractions. Fractions means one integer as a numerator, another integer as a denominator. Right? So the numerator and denominator both integers. Sometimes we think pi over 2 is a fraction. No, pi over 2 is not a fraction. It's not defined as a fraction. Maybe you can treat it as a fraction because pi is an irrational number. It's not an integer. So the formal definition of a fraction has to be the numerator is integer, the denominator is also an integer. So to help, whatever the real number cannot do, so we created an imaginary number, which will make this I square equal to -1, but the I itself is a square root of -1, which does not exist in real number world. And this such I is a cyclic. You see, I equals the square root of -1, but I square equals to -1, which is I square is a real number. And the I cube is a negative I, imaginary number. Then add to the fourth power, again, turn to be real number. So add to the fifth, go back to I. So I has a circle of 4. So put a real number and the imaginary number together, we call complex number. So complex number, we have a real part, we have an imaginary part. And B multiplied by I indicates B is the imaginary part. Let's say 3 plus 2I. 3 is the real part. And the 2I, 2 is the imaginary part. So those are numbers. And with expressions, also we need variables. Right? We use letters, we use symbols, we use Greek letters, or any symbols to just as a temporary value holder. You can imagine as an empty container. You can put any fruits, any veggies in it. Or those letters, you can assign any values to it. So it's a variable. Variable, it changes. It changes. So versus all the numbers, we call constants. Constant. Why is constant? Because it doesn't change. So constant versus variable. Variable changes. Constant doesn't change. Okay, with expressions, we have a very important family called polynomials. Right? With one term, we call monomial. Mono means one, just one term. Or maybe you will see, oh, I see 3, I see x, I see square. How could you call this a monomial? In mathematics, multiplication is like a glue. Multiplication or division is like a glue. Glue the numbers and variables together. So we call them one term. We don't see plus minus. Plus and minus separates terms. You see binomial. Why we call this binomial? 3x is one term, 2 is one term. We have an addition sign here. Bi means 2, so we have 2 terms. Trinomial, tri means 3 terms. Right? You see, we have addition, we have subtraction. So addition, subtraction are dividers, are separate the variables and numbers into different terms. So, right, you can keep going, then we just call polynomials, right? Polynomials degree n. If we have 3x raised by the nth power, it's just polynomial degree n. Then another family you call rational expressions. Well, what do we mean by rational? Rational means almost like fraction. Right? Rational means the variable appears in the denominator. The variable appears in the denominator. So we call rational expressions. And the numerator is a polynomial, and the denominator is also a polynomial. And oftentimes, we want to simplify rational expressions to its simplest form. Exponential, right? We'll see exponential. No, exponential means the variable appears in the exponents of, let's say 3 raised by x, right? The variable appears in the exponent as exponents, so we call exponential form. Then logarithm, so it's logs, right? Log base a of b, log base 10. If it's base 10, by default, we don't need to write it. Log e, Euler number, base means log, base e. And then trigonometry, sine x, cosine 6x. So 6x is the angle, tangent of x squared plus 1, so on and so forth. And then we also have radical expressions. Radical expressions, we have nth root. So this n is the index, nth root. And this m is power. And we can write radical expressions with rational exponents. So the power is the numerator. The index is the denominator in the exponent of x, right? By default, if the index is 2, we just don't bother to write it. It's just by default. So that's expression family. Extended expression family, if we add an equal sign, that makes equations. So whenever we see equal sign with mathematics, we know that's an equation. So linear equation, we see bx plus c equals 0. Why we call linear? Because the exponent of x is 1. When the exponent is 1, we just don't bother to write it, just by default, right? So it's called a linear equation. Quadratic equation, we see x squared. So we see a variable raised by square. Well, this keeps going, right? Keeps going. We can have raised by cube, raised by 4, so on and so forth. And degree n polynomial equation, we have this, right? We see x raised by n, and this one called leading term, because this term has the highest exponent, so we call leading term. And this an here, an just represents some numbers, right? An we call leading coefficient. The next one is rational equation, right? With rational expression, we add equal sign, add some value to the other side, or some expression to the right-hand side. We make a rational equation. Same thing for radical equations. With radical expressions in it, with equal sign in it, we call radical equations. Exponential equations, right? Exponential expressions with equal sign, with some other expressions, makes exponential equations. Similarly, for logs, right? If we see equal sign, we see log expressions in it, that makes log equation. Same thing for trigonometry equations, we see trigonometry expressions with equal sign, then that makes trigonometry equations. And differential equations, this is a little bit higher level. This involves calculus, different derivatives, right? Differential equations. System of equations means, we put a couple of equations together. We want to solve for the variables for the system. And then we have expressions. We add equal sign that makes equations. Now functions. So functions means we just have this notation, function of x equals to something, right? So in this case, we have constant function, f of x equals c. C is just a number, it's constant. So this function doesn't change. It stays forever to be c. Doesn't matter what x is, it stays to be c, so that's constant function. Linear function, we talk about linear equations, right? Linear function, we just have f of x notation, function of x function in terms of x. So this function, we call this f of x function value. It depends on the x value because b and c supposed to be some numbers. So this the function value depends on the independent variable of x. It's linear because the variable x raised by 1. So the exponent of x is 1. Quadratic, right? X raised by square is the leading term. So polynomial function of degree n, we have f of x equals to such polynomial expression, and the leading term is a n x raised by n's power. Rational functions, we have rational expressions, then we have f of x equals that. We see this is the equation, but it's limited to f of x, so it makes a function. Same thing for radical functions, right? We have f of x equals to some radical expressions. Same thing for exponential functions. We just see f of x is equals to some exponential expressions. Same for log function. We see log expressions involved. Trigonometry functions, we see f of x equals to some trig expressions. So as you can see, if we categorize basic or fundamental mathematics, train our brain to think, oh, you know what, I'm only dealing with 3 things: expressions, equations, and functions. Then, yeah, we'll go from here.